Welcome to Azure Conf. My name's Eric Boyd, and for the next hour, I'm going to be talking about optimizing performance in Microsoft Azure SQL Database. I run a consultancy in the Chicago and Milwaukee area, and I help customers all day long with migrating workloads to Microsoft Azure, building applications on Azure, optimizing performance in Azure. In addition, I'm also a Microsoft Azure MVP, and Lenny Lobel and I recently authored a book called Step by Step Microsoft Azure SQL Database for Microsoft Press. I say all that to let you know that I live and breathe Microsoft Azure and SQL Database, and so this is a topic that's near and dear to my heart and what I do most often day to day. Our agenda for the next hour is I want to explain the SQL Database architecture so you have some fundamentals and understand what SQL Database is all about. From there, we're going to dive right in to performance optimization and how you can make your SQL Database perform really well. So we're going to talk about how you manage connections in SQL Database. We're going to talk about how you can monitor performance of your SQL database, how you can scale your SQL database, both up and out, and how you can get started with new SQL database service tiers. Before we get too deep into performance, let's talk about SQL database all up. SQL database is just like SQL Server in the sense that it's the same TDS protocol as SQL Server on premises. It's the same port 1433 that we connect to SQL Server on premises. And we use the same tools, Visual Studio, SQL Server Management Studio, third-party tools like Redgate SQL Data Compare. All those tools work with SQL Server or Microsoft Azure SQL Database. We also use the same T-SQL syntax as SQL Server. We just have a few variations. We have some things we can do in Microsoft Azure SQL Database that we can't do in SQL Server and vice versa. But overall, it's the same syntax. SQL Database is also extremely resilient. And what I mean by that is it's highly available, it's fault tolerant. Microsoft provides up to a 99.99% service level agreement for SQL Database, which means if we drop below that threshold, if we have an outage or downtime beyond that 0.01%, Microsoft will financially compensate us for that downtime. We will get money back for our SQL Database service. The databases are also replicated. So whenever we write data to SQL Database, it's on 3 different database nodes, on 3 different servers. And so it's always highly available and fault tolerant for us. And the way SQL Database works is whenever we make a request, a connection back into SQL Database, SQL Database routes it to an appropriate SQL Database node. Databases can be replicated to other data centers as well. And we'll talk a little bit about that as we start talking about the new SQL Database tiers. The good news is all of this is managed by Azure for us. We don't have to manage the servers. We don't have to manage the infrastructure. Microsoft does that for us, and Azure does that for us. SQL Database is also scalable. You can scale up and get better performance. You can buy larger and larger SQL Database instances, if you will. And you can scale out. You can scale out across multiple databases. Now that scale out mechanism is not built in, and we'll talk about how you can scale out and build that pretty easily yourself. And you can also architect solutions to mix those up. So you can have some scale up scenarios and some scale out scenarios and a combination of both in your solution. Now SQL Database is a multi-tenant service. And what I mean by that is customers share the same physical resources. So there might be a number of different customers with their databases on the same physical server and same physical disks. Now, the good news for us is this enables us to save money on the service because we're not buying all the physical resources. And so if we don't need all of those physical resources, we don't have to pay for all of them. And so we get a great economic benefit by having this multi-tenant service. However, multi-tenant services are tricky. And so there's a few models of multi-tenancy that exist today that are commonplace for services like SQL Database and cloud services in general. And the first would be a take what you can get model. So basically we're all fighting for resources. It's kind of a land grab. We grab as many resources as we can get and we use those. And so we potentially have contention across the different tenants. You hear terms like noisy neighbor, where we can kind of collide and impact each other's performance. And so things like policed resources come into play where if the framework detects that, if the service detects that, that sort of noisy neighbor, we're using way too many resources than we should, then we might get throttled back or policed, if you will, on those resources. Now, we'll talk about how these fit into SQL database as we move forward, and then the last option is dedicated resources, where we have carved out our own dedicated slice of the physical resources that's ours. Whether we use it or not, it's carved out for us, and it gives us some predictability so we don't run into contention and issues that we would with the other models. Web and Business Edition and SQL Database are what we've really had for the longest time. It's the SQL database that we've always had in Azure, and its model is really that take what you can get policed resource model. So in Web and Business Edition, we can spike and get lots of resources and get great performance. We can also have kind of poor performance if there's a lot of contention on the box, if we have a lot of noisy neighbors. And then what happens is our resources get policed and we get governed and throttled back. And so we can have connection drops because we're getting throttled, because we're doing too much on the server. And these editions are not based on performance. They're based completely on database size. So you buy a web edition, you buy a 1 gig web edition database, and then if you want a larger database, a 5 gig database, you would size that up and you would pay for that 5 gig database. You could go to 20 gigs and beyond with Business Edition, and we pay for the size of the data that we're storing, but not the performance. Nowhere do we carve out our performance. And so what we have is unpredictable performance, where we have spikes and we have kind of low valleys of performance, and we get connections terminated by that policing mechanism, that governor. So when we start thinking about performance optimization, one of the things we need to do is just go back to the basics and the fundamentals and think about how we use those resources so that we're not getting policed, so that we're not getting throttled as best we can. So we want to open connections late and close them early. These are kind of common principles that we think about when working with relational databases and resources where we're holding on to expensive connections like SQL Server. And so open those connections as late as possible in your process to get data, to update data, close them as early as possible. In addition, we want to pool those connections, and so by default, clients and .NET are pooling connections so that we have a pool of these to use, and they're not physically getting closed on the client. And then limit the size and the shape of your data. And so if you don't need 1,000,000 rows, don't return 1,000,000 rows. And if you don't need all of the columns, then don't ask for all of the columns. So limit that to what you need. That will save on bandwidth and data transfer and that sort of thing as well. And tune your queries. And so on premises, we often throw more hardware resources at problems. In the cloud, we often think about things a little differently, and we try to optimize our usage because we are paying for our consumption, our usage. And so optimize your queries, tune your queries to perform better. In the meantime, there are ways for us to bridge those gaps with service levels that give us better performance, and we'll talk about that as we move on. So first thing, we need to manage our connections. Connections can be terminated when we have things like hardware failures, when we get balanced to another server. So with SQL Database, again, our data is on 3 different storage nodes or databases, 3 different database servers. And when those connections come in, if there's contention on a box, if performance is not great on a box on one of those nodes, then Microsoft and Azure can bounce us over to a different server. And when that happens, connections to the client will be terminated. We also could get terminated if we're consuming too many resources. So that policing mechanism comes into play. If we get governed and we get throttled, then we will end up with a connection loss in the Web and Business Edition. And if we take too long to do what we need to do, so if we have a connection that's running just too long, we have a query that takes too long, we could get throttled as well, and that connection would get dropped again. Now, in these scenarios, this connection loss, this connection termination is not a long-term termination. In all of those scenarios, it's a short-term termination. With that in mind, it's a temporary loss that we should retry. And so if we build in logic into our applications to attempt to retry that connection again, it'll often succeed the next time around. And we can retry multiple times. And we refer to this scenario as a transient fault. And transient just means temporary. But we should retry whenever those transient faults occur. Now, how do you know if it's a transient fault? This is a row out of the event log table for Azure SQL Database. And I'll show you how we can query this later. But when we have a SQL exception that occurs, and we capture that SQL exception in our application, we will get a reason code back. And in this case, this reason code is 8,194, and we got throttled. You'll see the event type says we got throttled. Why did we get throttled? And so for us to optimize our application, we need to understand why we're getting throttled. And so there's a mechanism for us to figure that out. You can take that reason code, 8,194, and in this case we have 131,075. But you can take that reason code and do a mod 4 on it. And whatever that remainder is, you'll see over here on the right-hand side, will tell us if there was throttling and why we got throttled. So if it's a 1, our updates and inserts got rejected. If it's a 2, all writes are getting throttled. And if it's a 3, everything's getting throttled. And so after that, if we determine that we're getting throttled, then we can take that same number, that 8,194, and divide it by 256. Now in this case, we're using 131,075. And we drop through and we divide it by 256, and that gives us an answer. We take that result and convert that to binary. And so in step 3, you'll see we group that binary result into sets of 2 digits. And at the very bottom, you'll see that charted out here for us. And you'll see our 10 falls into this column that's 4. And so if we go over and we look to figure out what kind of resource type was being throttled, we'll see 4 maps to CPU. And so our CPU, we were getting throttled because of our CPU utilization. And our throttling type is a hard throttle on this resource. And so this gives us the information about why we're getting throttled based on those reason codes. Now this is how we would determine if our exception here, if our connection loss is transient, temporary, or not. And there's an article here on MSDN that walks through how all this works as well. And so there's the link for that. But that's a lot of work. And so don't reinvent the wheel to accomplish all of this, because this has already been done for us. There's libraries that do this for us without us going through all of the error codes that could possibly be a transient fault, or without us going through that big diagram to determine that ourselves. But that's a good way. If you see an error code in your logs, you can go back and figure out what happened. So with that, ADO.NET Entity Framework in version 6 provides a new class, SQL Azure Execution Strategy, that will allow us to take a look at and retry any sort of transient errors that occur. So with that, let's go over to Visual Studio. I have a very simple sample application. It's just a web app. I'm going to run it just so we can see it in action. And this is an app that we used, or a database at least, that we used throughout the step-by-step Azure SQL Database book. And we called it Wine Cloud DB. And it basically is a catalog of wines and customers and orders and that sort of thing. So this is a very simple MVC app that has this catalog of wines, and we're displaying that. There's also an API behind this, so I can go API/customer, and I can see all of my customers. I can go API/wine, and I can see my list of wines. Now, inside in Visual Studio, if I stop this, and I go to my entity framework, my data project that has my entity framework context and my DB configuration classes, if I open up that DB configuration class, you'll see this line right here. And this line is what just automatically an entity framework for us enables retries. And so if we set the execution strategy and we say, let's use SQL Azure Execution Strategy, whenever a transient fault occurs, it's going to retry. Now we can configure the retries as well. So over here in the constructor, we can pass in a max retry, how many times we want it to retry, and the delay between each retry. And so max retry count is how often we want it to retry. Max delay is how many times or what that delay between each retry is. And so this is a way to do it with Entity Framework. I'm going to close that. And I'm going to go back to our slides. Now, in addition to Entity Framework, the built-in mechanisms in EF6, we have mechanisms provided by the Azure Cat and Patterns and Practices team. We have an application block basically for handling transient faults. With this block, we have a lot more kind of capability and flexibility. It works with SQL database, but it also works with other storage services in Azure, like Service Bus or blob storage and table storage and that sort of thing. So we can use it across the Azure services, not just SQL. And it's very easy for us to do this. So using NuGet, we can go find the enterprise library package and install it into our application. So I just searched here using the phrase transient fault SQL database, found the enterprise library application block. That's the transient fault handling application block for data, and I installed it into my application. Now, our application block, the transient fault handling application block, provides three basic things. It provides a detection strategy that tells us, is this error, is it a transient fault? Is it temporary? If we retried, would it recover? Would we be able to have success with our connection? And then we have a retry strategy, which is how often and how many times do we want to retry when we detect a fault. And then a retry policy basically combines that detection strategy and that retry strategy together for us, and we use that to execute our requests back to SQL database or whatever underlying service we're calling. We have multiple retry strategies built in as well. We have an exponential backoff strategy that lets us exponentially, over a specified number of times, exponentially back off the retries and delay the retries. We have a fixed interval strategy, which we can specify the number of times we want to retry and a fixed interval between each retry. And then we have an incremental strategy, which is, again, a number of times incrementing the interval between each retry. So with that, let's go take a look at the transient fault handling application block. So here in Visual Studio, I have my WineCloud site project that's talking to my WineCloud database. And in my data project, I have a customer, which is, it's just a very simple POCO object, POCO class here in C#. So it's got my customer ID, my first name, my last name, and a favorite wine. And then I also have a wine. And my wine class has a wine ID, a name, a category, a year, and a price. Now that gives you a little info into what our data structures look like. If I go over to SSMS and I look at our database, you'll see they map one-to-one here. So my customer, I have a customer ID, a first name, and a last name, and a favorite wine ID, just like I had in my class. And in my wine, I have a wine ID, a name, a category, a year, and a price, just like in my class. And so that's the database we're using in our API and in our website that these classes are mapping back to. Now, I have these in, if I look at my context, you'll see that I have wines here, but I do not have customers. And so let me just show you what our customers look like. If I go back to my web project, I have my web API here, and so I have a customer and a wine web API. And so if I look at wine first, what you will see is a very simple Entity Framework web API controller. And so I'm getting wines and I'm getting the list of wines from that DB context that's up in our data project. And I just keep going through here, and all of these methods in our web API are using that Entity Framework DB context. So you'll see here I've got an update that's a put. And again, I'm just saving changes on a DB context. And I have a post or an add here and a delete. But you don't see anything special here in this API. It's all just using Entity Framework. There's no retry logic at this point built in or that sort of thing. Now if I go look at my customers, my customer controller, it's different. I'm not using Entity Framework for that, and I'm using it just as an example so you can see how we can do this with and without Entity Framework. And so this is just using raw ADO.NET classes. And so here I'm getting, I'm setting up a list of customers. I'm going and getting a connection string from configuration for our Azure SQL database. I'm setting up a new connection. I'm getting a list of customers, executing a command to do that, setting it up at least. And I'm opening our connection. Now this is important. Let's remember this because we're going to change this as we move forward. I'm opening a database connection and I'm executing a reader on that command object. Again, those two lines we're going to change to deal with retries and those transient fault cases. And if I go down, I do the same thing down here when I get by ID. I have a connection string, create a connection, open the connection right here. I execute the reader again right here, but again, nothing special at this point with retries. And I'm taking all of those customers, all that data that comes in from that reader, mapping it back to that customer class and creating customer objects, and I'm adding them and returning them, and then adding them to the list in the case of get list and returning that list. So nothing terribly complex here. But what we want to do at this point is add in the transient fault handling application block. So if I right click and I go manage NuGet packages and I look at all my installed packages, you do not see the transient fault handling application block in this. If I go search and I say transient fault SQL database, I go online first, transient fault SQL database, we will see the enterprise library packages from NuGet for the patterns and practices transient fault handling application block. And we see a few. We care about the one that's the data block for Azure SQL database. Now I'm not going to add all this in manually. I've already done this, and so what I'm going to do is go over to a Git repository, and I'm just going to pull in my changes just for the sake of the demo. It'll make it a lot quicker than watching me write a bunch of code. All right. So now what we have is if we look at those NuGet packages, we should see in our list of installed packages, we have the transient fault handling application block. So all we did was add that application block in. We didn't make any changes in our data project. All of our changes we're actually going to do in the controller. So if I go down to our controller and I first go to our wine controller, actually, I need to pull one later change here. All right, there we go. So if I go to our wine controller, you'll see I've brought in, I've got a using here for the transient fault handling application block, and I set up a retry policy. I'm going to close this up here so we can see this a little better. I set up a retry policy, and I use the SQL database transient error detection strategy. Now that's an error detection strategy that's built in for us. We didn't have to create that, and so that's the piece that's pretty complex in terms of knowing what errors are SQL database transient faults. And so it's great that we didn't have to create that and we could just leverage that from the library. But if we wanted to, if we had our own custom scenario where we had a service that we're depending on that has this transient fault behavior, we could create our own detection strategy and detect when these temporary errors occur that we could just retry and recover from. And so, you know, I've done this with things like HTTP, calling web APIs or something like that where there might be a temporary failure, a network failure or something like that, and then you can retry it automatically, build your own detection strategy to say when these status codes come back, retry, that sort of thing. But whatever your scenario is, you could create your own detection strategy. In our case, we're going to use the built-in SQL database transient error detection strategy. If we keep going, in our constructor, we go out and create a retry strategy. So we new up an incremental retry strategy, and we want to retry it 5 times. So whenever a transient fault occurs that gets detected by our detection strategy, we want to retry up to 5 times. Next, we have the interval to retry. And so when do we want to start the retry? And we want to start it in a second. And then we have the last is how long do we want to increment the retries? And so we want to start from a second. We want to retry incrementally every 2 seconds. And so we would retry 1, 3, 5, and on every 2 seconds. So that's our retry strategy. We want to wrap that up in a retry policy. And so that line right there is creating and newing up a retry policy, setting our field to that, and we're newing up a SQL database transient error detection strategy with this retry strategy that we've created, this incremental retry strategy. So now we have a retry policy. Now what do we do with that? Well, retry policy has an execute action method that takes an action. And so in our getWine method that was just this line returning wines, we have now wrapped that in our retry policy using a lambda, and we're executing the action that's going out and getting those wines. Now, we're just wrapping the data access calls. That's all we care about, is anytime there's data access, if an exception occurs that gets detected as a transient fault, we want to do something, we want to retry. And so that line right there, if an exception occurs that comes back and it is transient, the detection strategy finds that it is transient, it will just retry that up to 5 times every 2 seconds. We do this throughout our API. So we're using that execute action method, passing in an action using a lambda, and it will retry that code for us automatically. And we're doing it all the way through. So there's our gets, here's our write action, so here's a put, doing an update, and so we're just wrapping that save changes calls that makes a call back to the database. And here is a post, the same thing, we're just wrapping the data access calls. And so that's pretty simple. That's our wine controller that's doing our wine web API. Now, that's using Entity Framework. We were able to wrap that call, and we could wrap any sort of call using that execute action method on the retry policy that takes in an action. But what do we do with raw ADO.NET calls that are not Entity Framework? Now, we could do the same thing. We could wrap raw ADO.NET calls and retry them using the retry policy execute action. But there's also some built-in support for us, some built-in objects. And so here is our customers API. And in this case, we have that same retry strategy we're creating. We're wrapping it up in a retry policy, just like in the last example. The thing we change here, though, is when we open a connection, we now call an extension method on connection that's provided for us by the transient fault handling application block that's open with retry. And when we call that, we pass in our retry policy. The next thing we do is our command, instead of just calling execute reader, which is how we had it before, we call execute reader with retry, again, provided to us by the transient fault handling application block. It's an extension method, and we pass in our retry policy. Now what that will do is if an exception occurs in this command and connection, it will retry that. And so you'll see here, all of this would get retried in that same interval, that incremental retry every 2 seconds whenever an exception occurs. And so we do that here in this get customer method as well, the same sort of thing. And so we can use those extension methods to leave our code pretty much the same as it was before we added in the transient fault handling support by just changing a few lines, adding a few lines, changing a couple to use those extension methods. So pretty simple. And if we run this, we will get our same wine cloud site. All should work just fine. And we should be able to call our APIs and get a list of wines back. There's our wines. We should be able to get a list of customers back as well. And so there's our customers. So nothing there has changed. Same behavior that we would expect. If a transient fault occurred, we would retry until we got those back. All right, so let's close these. Let's go back to Visual Studio. Nothing else has changed in our project. It's really just those two controllers, and we've added a reference using that NuGet package to the transient fault handling application blocks. And again, the value of transient fault handling application blocks is it's a lot more robust than just what's built into Entity Framework. Even if you're using Entity Framework, you might consider that. You can build in your own detection strategies. You could use it for other services as well, not just SQL. You could use it for storage. You could use it for service bus and other things. So it's a much more robust way to do it than just what's built in with Entity Framework. But in Entity Framework, if you have a simple scenario, you could definitely use that and get by just fine. All right. Now earlier we saw a row from a query that told us we had a throttled connection. And there are a couple of system objects in the SQL database that give us information about our connections. The first is sys.database_connection_stats, and that gives us a summary by time of our database connections. The second is sys.event_log, and that gives us very detailed information about connectivity events. So the connections that are occurring, if they got throttled, that's where we got the information, that row back from SQL database to tell us we had a throttled connection and here's the reason code. So if we go over to, let's demo this a little bit, let's go over to SQL Server Management Studio. I have two queries querying those objects. Now I'm connected back to master in SQL database, just like SQL Server on premises. We have a master database, and in here we have system views, and we have these objects that we can use to query and get information about the health of the server. So if I run this, let's collapse this down a little bit, you'll see a time-stamped sort of reporting in a summary view of our database connections back to SQL database. And so let me zoom this in a little bit. You'll see here this 1230 to 1235. We had 10 successful connections. We had no failures, no terminated connections, no throttled connections, all as well. If we scroll down a little bit, you'll see later on, let's choose this one right here. Later on we had 2 failed connections, 2 terminated connections, still no throttled connections, but we are seeing some different results. And so you can use this, you could query this, monitor it, you could set up jobs to report on this if you wanted. Later on, I even get a little wild and start making lots and lots of database connections back to this database. And so you'll see we have 1,800 and change successful connections back to our database, and on and on. And so we're making lots and lots of connections during that 5-minute period, each one of these 5-minute periods. So that gives us a summary of, for a database, between this time and this 5-minute block, what do our connections look like? And so we can see that we could chart it out and do some interesting things with that data. Now I want to get down to the nitty-gritty and the raw sort of connections. And so there's the event log object here that will give me a lot more detail on what happened. And so you'll see here, here's a list of successful connections. I have a successful connection. There's 10 of these, all as well during this time period. If I keep going, you'll see I have connections getting timed out and terminated. So you'll see that event type is a connection got terminated because it timed out because it was idle. If I keep going, I have connections failed. So you'll see I got blocked by a firewall and it tells me my client IP isn't allowed to access the SQL database. So I see all sorts of detailed information here. If I had throttled connections, I would see that throttling occurring as well here. And so here's a termination from a reconfiguration. And so this is the scenario where Azure decided to move me to a different node, a different server. And so it dropped my connection to do that. And so I need to reconnect. And so this is where handling those transient faults become important. but it's not because of throttling. In this case, it was just because it got reconnected, it got bounced over or failed over to a different server for some reason. And so that's some detail about the connections themselves and why the state and the events that are occurring and what's going on with the connections themselves. All right, in addition to just connections, we can monitor other things like the database, the execution stats and details, transactions as well, so things like locks and transactions that are going on in our database, using dynamic management objects. Very similar to SQL Server on premises, we have some dynamic management views and functions that we can use and query and use in some queries to determine what's going on in our database. And so, for example, here's a list of dynamic management views that are database specific. And so we have views for things like index usage, so I can see if an index is being used and the operations that are occurring against that index, how they're being used. I can see queries that return details about missing indexes, so indexes that SQL database thinks I should have that I don't. I can see information about partitions and weight stats for my database. In addition, I have functions that I can kind of integrate into some of these queries to return additional information. And so I have, operational, physical stats that I can bring in as well, and information about the database columns and indexes that are missing as well. So with that, let me just show you a quick example of a database DMV and a query against that. And so I'm looking at the partition stats right now. And this is telling me how much data my SQL database is using. Now over in the connection stats, I connected to master. In this case, I'm looking at the individual database, and so I'm connecting to the specific database, my database, not just master, my user database in SQL database. And so with this, I'm just asking for the page count, the reserved page count from partition stats, and I'm doing a little math to convert it to megabytes so I can see the size of my database. And so down here, you'll see that my database is really, really small, and I'm using 2.5, almost 2.6 megs of data in my Azure SQL database. So pretty simple, but there's, again, a list of these database views, dynamic management views and functions that I can use to get insight into how my database is performing. And again, things like missing indexes are extremely valuable when you're trying to tune those queries and get kind of stats around how to best improve the performance of your database. In addition to database dynamic management objects, there's also execution dynamic management objects. And so missing indexes are great, but I also want to take a look at the execution plans and how the queries that are occurring, how the execution plans look, where there's opportunities for me to optimize those queries and make them more performant. And so these are extremely valuable, and I use these regularly with customers when trying to optimize performance of their queries in their SQL database. And so I can look at cached plans, connections, query stats. In addition, there's functions, just like in the database dynamic management objects. There's functions to help me get the details of a query plan or the SQL query itself using the dm_exec SQL text dynamic management function in my query. And so that helps me really just get more detail around what's going on at execution time against my database. So with that, I'm going to go back over to SQL Server Management Studio and just run a very simple query here that's going to show us our active connections. And so here's it's querying exec sessions and exec connections, joining that up, and just returning the columns that I care about. So who's logging in, what their session ID is, when they made a request last, and how much CPU time they're using. I can even get connection ID, and there's a lot of other columns that I can get from this query. These are the ones I care about in this case. And so these are great. This is great insight when you're trying to tune and optimize your database and figure out who's using what and how much are they using and when are they using it and that sort of thing. So I can get these sort of stats from SQL database using the DMVs and the dynamic management functions. All right. Lastly, there are transaction dynamic management views. Now, these are getting information about the transactions that are occurring, locks. So if I'm trying to debug things like deadlocks and that sort of thing, these DMVs are extremely helpful. There's a small set of transaction DMVs. There's not any dynamic management functions, but these would be useful when you're really trying to debug that transaction level and locking. All right. So we've talked about monitoring. We've talked about connection management. Let's talk about scalability. SQL database provides a couple of scale options, or I can scale in a couple of ways, rather. I can scale up. Now, in Web and Business editions, all I could scale up was the amount of storage, the size of my SQL database. I couldn't scale up performance, but the new service tiers, and we will talk about those here shortly, the new service tiers enable me to scale up the performance so I can get faster SQL databases. I could also scale out. Now, this is not something that's built in, but it's not trivial. I don't want to oversimplify it, but it is doable to partition and shard your database across multiple physical databases. And that gives me limitless sort of scale. If I can kind of granularly split up my databases into multiple physical databases and query across those and use those effectively, then I can scale that out regardless of the service tiers that Microsoft and Azure provide me with my SQL database. There are a couple of ways we think about partitioning and scaling out. The first, which is pretty common, is partitioning by function. And so we could create multiple databases for each kind of silo or type of data in our applications, in our systems. And so in our case, in our Wine Cloud DB case, I have wines, I have customers, and I have orders. I could easily create a customer database and put that customer data there. I could create a catalog database and put my wine catalog, my product catalog there. I could put my orders in another database. I could put vendors in a different database. And this is one way to distribute that load and partition. The challenge with this approach is it's rarely distributed equally. And that's okay. We can choose different sizes of our database in Azure SQL Database for each one, and it lets us kind of split it apart. But what we really would like to do is figure out a way to distribute the load evenly across multiple nodes. And so that's where we have to start thinking about sharding our database in a different way, partitioning in a different way. And so let's take that customer data, for example. And in my sample customer data, I just have 3 rows. I have 3 customers, and so we're going to shard with those 3 customers. It'll be pretty simple to understand like that. We're going to create a database that's a physical database for customers, and we're going to call it customer shard 01. And we're going to put 1 record in that database. Now, again, this example is not it's not how you would really do it. You would put lots and lots of records likely in this database, but in our example, we're going to simplify it and just put 1 of our customers in shard 1. So we have a logical customer database that has multiple shards, and here's the physical databases behind that, customer shard 1, and then we have customer shard 02. And we're going to put the other 2 customer records in that database. Now, somehow, our application needs to know where these rows are saved, what database they exist in. So if I'm looking for Jeff Hay, I would want to know to go to customer shard 01. And I might do that based on the customer ID. I could do that in all sorts of ways. In our example, we're gonna map those by customer ID, but we need a map to know where to go find this data. And oftentimes we would create some other database or data store of some sort to store our map of where our records are. And so we'll call that shard map. In our example, I'm just going to code that up inside of our application. I'm not going to store that off into a separate database just for simplicity reasons, but practically you would store that somewhere else like a database, and you might even have multiple nodes for that as well to make that performant, because you don't want to bottleneck, you don't want to end up bottlenecking on that shard map. So it would do you no good if you were querying that shard map and everything was central to that and bottlenecking there. So you might have to scale that a little bit as well. So let's take a look at how we would shard our customers. Now again, if I go back to our customer controller and I look at our customer API controller here, you'll see that right now I'm just going out and querying a single database, and I am grabbing all of our customers. Very simple query. And if I go and I'm looking for a specific customer, then I'm just grabbing that customer where that customer ID equals the customer ID that I'm passing in. And again, just connecting to one database. So now what I'm going to do is I'm going to pull in some changes. I have, let me discard those changes. I'm not sure what those are, but that's okay. All right, so we pulled in some changes here. Let's discard that. It's refreshing our code in Visual Studio. There we go. So I'm going to close that, and I'm going to go back up to our data project and show you the classes that I added. So to begin with, I need a way to represent our shards. And so first I'm going to take a look at this shard class that I've created in our data project. And I have an ID for a shard. I have a begin ID. I have an end ID, which is my range of primary keys that I'm putting in that database. And then I have a connection string. And so this is representing for a physical database, so customer shard 01, for example. Here's the range of IDs to expect in that database, and here's the connection to that database. Now I need a way to group all of those together. So I have a shard root that gives me a list of shards, and then I have an implementation of that called customer shard that's giving me a singleton back to this customer shard class. I have the shard root here, and if I keep going down, what you will see is I have created that shard map right here in code. So when I constructed the customer shard, I've created a shard root. I'm adding shards to that shard root, and I have created a shard with the range of IDs 1 to 1. So I want that one customer in shard 01. And here's the connection string back to that shard. And so here's my Azure SQL database connection. Here's the database itself, and all of the other information to connect back to that database. And then I have the second shard with the starting ID of 2, the ending ID of 3. So I'm putting 2 records in there. And there's shard 02 again with the connection string. And when I get the shard, I have a method that I can pass in an ID. So in this case, the primary key, the customer ID. And I ask for the shard where that ID is in that range. So if I was looking for customer 1, then I would use this get shard method, pass in 1, and it would return me the shard that's in this range. Now, this is a great way to visualize this and think about how this is really happening, but you would likely bring this logic outside of your application code and put into configuration of some sort, whether that's XML or another a SQL database that's doing the mapping, some other data store that you can use, probably not in your application code. But this does a great job of kind of explaining and visualizing it for us so we can get our head around this idea. All right, so now if I go back to my controller, my customer controller got a little more complex. Let's first, before we look at this method, let's go down to customer, because it'll be a little simpler. So I have a customer that I'm returning. I have an ID that's getting passed in. I go get a shard, and I say, customer shard, give me a shard, the shard where this customer ID lives. And then that sets up my connection string. Now I still have all of the transient fault handling capabilities in here. I didn't get rid of that. But I have a connection string back to my shard. Now, everything looks pretty much the same. I didn't change anything. I have, opening a connection back to that database. I'm querying for a customer where the ID is the customer that got passed in. I'm mapping it back to a customer and I'm returning it. So the only thing that's different here is the very top where I have to figure out what database I want to query against, what shard, what physical node I want to query against. And so it uses that shard map to return that. But what happens if I want to get data across all of the shards? I want to query across all of them. And so in the get customers example, that's exactly what I want to do. I want to return a list of customers. I want to return all customers across all the databases. So I want all 3 records returned back as one result set. And so in this case, I'm optimizing that by using the task parallel library and doing a query across each of those shards in parallel. And so in this case, I'm saying, give me, loop through the shards, set the max degree of parallelism in this parallel for each to the number of shards that I have, and then execute this query. And so here's the connection string for each of the shards. Give me all of the customers for each of those shards. So just select every customer in the customer table across each one of those databases. Loop through a reader, add the customers to this shard customer list, and then at the bottom, when we're done executing that parallel for each, go ahead and add those shard customers, that list, into the customers that I want to return, add them all back together and return them. And so using the task parallel library, doing them in parallel across the shards are making it such that we're not waiting to go query each one. We're issuing those queries all at once, aggregating the results back together and bringing them back to our application. If we did them serially and sequentially, we would slow down our application performance waiting for each query to occur. So we want to do those as efficiently as possible using parallel and multi-threading technologies like the task parallel library. So with this, if I go back over to our database in Azure and our server in Azure, what you'll see is I have 2 shard databases. I have WineCloud DB shard 01 and I have WineCloud DB shard 02. Now in this case, I'm just sharding customers, and so what I've done is I've put the entire wine catalog in each one of these. But the schemas look exactly the same. Nothing changed in my database itself. And so if I go query this database, let's give me a new query here, and I select the wines, you'll see the entire list of wines. But if I select customers, you'll just see the one record, Jeff Hay. Now if I go do this with the second shard, again, you'll see the entire list of wine. But for customers, you won't see customer 1, you won't see Jeff Hay, you will see Mark Hansen and Jeff Phillips. So we just have 2 records and 1 record in the other case. Now, in my case, I've used wine like reference data, and I've included it in every shard. And that's what you would often do with reference data, is included in each one. You may, this is not, in practice, you probably would pull wine out and put it in its own database as well. But in this case, it works really well for us to think of it like reference data and just focus on the customers. So now I want to see this in action and see if this really works. So I'm going out and querying multiple databases all at once. So if I call this customer API, what I should see is a list of all my customers getting returned. Now, different than we saw earlier, because the task parallel library is going out and querying those in parallel and bringing the results back together, I didn't do anything to sort them by customer ID when I brought them back together. And so you'll see that the task parallel library must have completed and brought in 2 and 3 before 1, and so it brought them in the list altogether. If I refresh this, you might get different order and results. And so you might want to think about how you sort and that sort of thing in that list if that matters to you. But in this case, it's just returning it and bringing it all back together for me. So I'm going against multiple databases here and bringing those results back together. Now if I go back to wines, I didn't change anything in wines. And if I go to customer and I just pull back an individual record, you'll see that works as well, and it just goes to the appropriate shard to do that. All right, so let me stop this. Now I showed a pretty simple example of how to shard with a couple of classes, some TPL code, but Cloud Service Fundamentals has a great kind of library and framework for you to start with to do things like sharding, and it has a little more robust library than what I've just shown. And so I would encourage you to go check out Cloud Service Fundamentals, and I should have, if we go bing this, it's pretty easy to find as well. And if I click on this, it's on code.msdn.microsoft.com, and you can download all this code and browse it as well from here. All right. Now, we've talked about scaling out, scaling across multiple databases, but what about scale up? One of the great new improvements in Azure SQL Database is something we've been asking for quite a while, and it's now become generally available for us, and that is performance tiers in SQL Database, so service tiers that are performance-based, so that we can have predictable performance. And to do that, we use a different model for multi-tenancy here. And so the model is not the, take what you can get in policed resources. It's really, you have your own carved out, dedicated resources. You will always have this much. If you choose not to use it, that's fine as well, but you'll always have this much, so it's predictable. Because what we had in Web and Business Edition was this kind of thing. We might have great performance, but we could drop down if there's noisy neighbors and that sort of thing causing problems on the box, and so we would have very unpredictable performance, and that makes it a little difficult to scale out across multiple nodes because we really don't know what the performance characteristics are that we can expect consistently. And so what we're really trying to achieve here with the service tiers is this sort of flat line. We don't want those peaks and valleys anymore. We want a consistent, predictable experience for our database. We have lots of additions to choose from. So basic is kind of the lowest tier, and there are a couple of factors that come into play, and I'm going to talk about DTUs in just a second because that matters a lot. But one of the things we get is a max DB size across all of these new additions and service tiers. And so before in Web and Business Edition, we paid for the amount of storage we had, the size of our SQL database. Now with these new SQL database additions, these new service tiers, we get up to a max DB size, but we don't pay for the size. We just get that. That's part of the resources that are dedicated and carved out for us. And so in Basic, we get up to 2 gigs. And then there are some benchmarks that Microsoft has done for us using a sample sort of workload. And this is the performance they have been able to achieve against these new additions with their benchmarks. Now, one of the things to note is the transaction rate is targeted differently for each tier. So for Basic, it's number of transactions per hour. For Standard, it's number of transactions per minute, and for Premium, it's the number of transactions per second. And I tried to extrapolate that out in this right-hand transaction per hour column so we can see what that really looks like instead of just looking at it by the hour or by the minute or second. And so you'll see from Basic to Premium and P3, it's a significant difference in the performance that you can get. Now, how is this all calculated? This DTU is a database throughput unit. And basically what that means is a DTU is a collection of resources combined together that give you some level of performance. So things like CPU, memory, all of that factored in together, combined together to give you some level of performance. Now DTUs are relative, so you'll see a range from 5 to 800. You pay for those additions and those tiers based on the size that you choose. So you'll see that perf level. For basic, there's just one, but standard has S0 through S2, premium has P1 through P3, and you can choose that level that meets kind of your needs based on the DTUs. Now, you will want to test your own application and your workload against these levels to figure out what's the right setup for you, what's the right size of database for your scenario. But in standard, you can have up to a 250 gig database. You don't have to have 250 gigs, but you don't pay anything more, whether it's 1 gig or 250 gigs. For premium, you can have up to a single 500 gig database. And you'll see, again, those DTUs vary based on the level that you choose. And so think about DTUs like VMs. So they are kind of governed resources carved out just for you. You have a VM inside of a physical box, if you will. That's the best analogy or metaphor I can think of to describe what a DTU really is a set of resources dedicated just for you. So think about it like a VM that's got dedicated resources on a physical server. So let's take a look at these new service tiers in Azure. So this is the management portal. If you're not familiar with the management portal, we haven't actually been in here yet today. But this is a list of our SQL databases. So there's our web database, our Shard01 and Shard02. If we come down and say create a new database, we can say custom create a SQL database, and we have the option of choosing the tier that we want, basic, standard, premium. If I choose basic, I have this one performance level, which is 5 DTUs. If I choose standard, I have S0 through S2, which gives us 10 to 50 DTUs, and premium, again, goes all the way up to 800 DTUs. Now we still have web and business over here, but these are retired editions. And so what does that mean? They are going to be around. They're not going away right now, but in September of next year of 2015, these editions will go away. So you have to start thinking about how can you transition to the new tiers, because web and business will ultimately go away. And so you just need to think about how you can transition your application in, what makes sense for you, test it to figure out what the right performance level is. Because again, web and business did not give us performance guarantees and characteristics. So you could get extremely great performance 20 minutes ago, and then 20 minutes from now, we could have significantly less performance in that web and business edition. So you'll want to test out your application. But when you already have a database, you can just toggle and change the addition of the database here back and forth. And so if you have an existing web edition, you can convert it and change it to a standard edition in the right level for you. Now what I want to do is go over to the new management portal, because there's a feature that some may not be aware of, and I think it's extremely valuable. When you create a new Azure database, for the first time you choose a server, create a server, that sort of thing in Azure. And so here I'm going to choose, let's create a new SQL database. And I get my new SQL database blade over here. And I can name my database, and so we'll call it Azure Conf Wine DB. I choose my tier, and so there's my basic tier, there's premium. I can choose the addition and the number of DTUs in premium as well, or standard and premium. In this case, I'm going to choose basic and select that. The feature that I think is really nice is when you go to create a server. So I can create a new server, and before in the old portal, you got a generated Azure SQL Database Server name. But in the new portal, it gives me the ability to name my server. And I need it to be Azure Conf SQL DB. We'll just name it that. Azure Demo. Create our password. and choose our data center. We'll do it in the west, since that's where we are today. Okay. And create. So now that's creating a new SQL database for me. That's something I could not do. It's creating a server as well. It's something I couldn't do in the old portal. I couldn't name my database server. But we will see that server show up over here in the old portal, and we can continue managing it over here if we would like. We could use the new portal as well. The new portal is really nice, provides a great DevOps experience, provides a lot more detail in some cases than we get in the old portal. So we'll let that go and create. All right. The other thing that I want to show is being able to scale the size of our Azure SQL database. So this is some PowerShell, and it's very simple PowerShell, just a couple of lines of PowerShell that lets us change the size of our Azure SQL database. And so right now, let's go back to our list of databases right now. You'll see that I have those two customer shards that I have we've been working with, shard 01 and shard 02, actually have different editions. So I have one that's a web edition, and I have one that's a standard S1. And so that's one of the benefits you get from sharding yourself and using your own sharding mechanism. You can kind of pick and choose how you want your shards to perform. So if you have a shard that isn't evenly balanced, you can give it better performance by choosing a different edition. In our case, I actually want to convert our shard 01 to a standard S1 and make them even. And there's our new database that just showed up. So if I go back over to this PowerShell, there's the server name of the server that we're using right here. And so the first thing you'll see that I'm doing in this PowerShell is I'm getting a login. I'm going to copy this. So I'm getting my credentials. It's going to force me to log in. And then I'm creating a context back to our server out in Azure, our SQL database server, with that login. Using that context, I want to get a hold of our SQL database. So if I go back, I'm going to get shard 01. It's a web edition right now. And I'm going to convert it to an S1 from a web edition. So I get the Azure SQL database. I get the service objective for that database, or get a service objective for that database, which is S1 in this case. I'm going to call this set Azure SQL database PowerShell command using the server context that we created up here, the database that we created here, the service objective that we created here, and I'm going to use a standard edition. So if I execute this, yeah, go ahead and save it. It's going to ask me to log in, and I'm going to log in with my SQL credentials. And now it's asking me, do I really want to make this change? It's going to change the cost of my database. Yes, I do. And so now it's going through. It executed that PowerShell. I'm all done. And if I go back to the portal, and it will show up automatically here for me in just a second, but I'm going to refresh to force it. If I go back to the portal, what I should see is the state of that change. The state of the database should show that it's changing additions right now in this addition column. So there it is. So web to standard, scroll over here a little bit, standard S1. So right now it's being converted. It's not converted yet. It does it asynchronously. My PowerShell command returns. It issues the request to make that conversion, but it's going to go from a web edition to a standard S1. Now, what if I wanted to programmatically determine what the status of that is? Using some SQL, I can query, here we go. So I'm querying a couple of objects in my database and joining that up with my database here to see what the status of, and I'm querying against master, of those changes are. And so you'll see I have a pending right here. Shard 01 is being converted to an S1 from a shared, which is web at this point, and it's pending. It's still being executed. So it's not, the conversion's not done, but I could keep watching this, and eventually when it completes, it will show complete here. there's also a way for me to look at the history of my changes. And so if I go back and look at SLO assignment history and I run this, you'll see here is a list of changes to the service objectives over time. And so you'll see when they were requested, when they started and when they ended, how long it took for that conversion, that sort of thing. So these are very useful queries to monitor the service changes. All right. So we've talked about a lot. We've talked about monitoring. We've talked about scaling both up and out. So scaling with the new service tiers up, scaling out by partitioning and sharding. We've talked about managing connections using the transient fault handling library and Entity Framework 6's retry mechanisms. So we've covered a lot of SQL database material and ground, but there's tons more that you could learn about with SQL database. And so Lenny Lobel and I recently finished this book with Microsoft Press. It's Step-by-Step Microsoft Azure SQL Database. And this will walk you through step-by-step from getting started all the way through to managing your database. A lot of the examples that I showed here came from our book. And so feel free, you can buy it on Amazon or anywhere that sells good tech books. But feel free to check that out. It's about 400 pages and walks you through in a very hands-on, step-by-step way Azure SQL Database. In summary, I want to make sure that I convey that SQL Database is familiar, resilient, and scalable. It's familiar to us as developers if we're familiar with SQL Server. It's resilient. It's highly available. You know, we didn't talk about all of the new features that exist in the service tiers, the new service tiers. There's new capabilities for business continuity and disaster recovery. We were just focused on performance. It's also scalable in that I can scale up, I can scale those additions up and get better performance. I could scale them out across multiple databases as well. You cannot avoid fundamentals and the basics when using SQL Database in Azure or SQL Server on premises. You have to consider things like managing your connections, optimizing your queries where possible, reducing the size of the data that you're sending over the wire, that sort of thing. And lastly, the new service tiers you should definitely check out if you're using SQL Database today and you're using Web and Business Edition. If you're thinking about using SQL Database, but you've heard that the performance isn't consistent and predictable, the new service tiers provide that consistency, predictable performance. You should definitely check out those new service tiers and figure out how your application fits in. So with that, if you have any questions, don't hesitate to reach out. You can find me on Twitter at Eric D. Boyd. You can find me blogging at ericdboyd.com. And you can email me. It's just simply eric@responsivex.com. So thank you for attending Azure Conf, and I hope you enjoy the rest of the conference.